Hello and welcome back to the Building HVAC Science Podcast, where Eric Kaiser and I are aiming to create better, more knowledgeable HVAC and building performance pros. We do that through these dialogues we have on the podcast. In this episode, Eric sits down with Haley Harlow and Al Mitchell from PHIUS, the Passive House Institute US, to explore the program called Revive 2024. It's a groundbreaking new retrofit standard focused on thermal resilience and healthier, safer existing buildings. Haley and Al both give us their background stories, very interesting to hear about. And together they unpack how Revive differs from traditional PHIUS new construction standards, instead focusing on heating and cooling load targets. Aha! Tie into the podcast, right? Revive emphasizes thermal resilience, and that would be a building's ability to remain habitable for up to 1 week during power outages or extreme weather. I tried that at my house. It worked for about hours, better part of a day in extreme weather. So even well-built homes can use some improvement. They also discuss ReviveCalc, which is PHIUS's new software tool for analyzing retrofit scenarios, allowing designers to test various upgrade packages, balance cost and performance, and phase new improvements over time. They share their excitement about addressing the massive stock of underperforming existing buildings. There's some key takeaways noted in the show notes, such as thermal resilience replaces traditional load metrics, ensuring buildings remain habitable during grid or system failures. And the program aligns with ASHRAE Guideline 0.2 for commissioning and integrates EPA's Energy Savings Plus Health Framework. Also, take note, the CPHC certification, that is Certified PHIUS Consultant certification, is open to anyone, no degree required. And take a look in the show notes for Haley's LinkedIn, Al's LinkedIn, and info on the PHIUS Revive 2024 website. Okay, now on to the conversation with Al and Haley and Elk talking about Retrofit the Future inside PHIUS's new Revive standard.
Hey everybody, Eric Kaiser here. Welcome back to the Building HVAC Science Podcast. I'm alone today. Mr. Bill Spohn is somewhere wandering about doing something, but we know he's not here. However, I got two very special guests, and we're going to learn a lot about a neat program that I learned some about earlier this year during an event called Building Science Summer Camp. And with me to really educate us on something are Haley Harlow and Al Mitchell from PHIUS. So welcome to the show, both of you.
Thanks.
Thank you for having us.
So the first thing we like to do around here is learn a little bit more about our guests. Haley, why don't you kick us off? Tell us a little bit about who you are, where you came from, and how you got to where you're at now.
I am currently serving as a building certification manager here at PHIUS. Most of my work is involved with the design certification side of our standards. I also do a ton of feasibility study work. I graduated from the Pennsylvania College of Technology. My degree was actually in building science and sustainable design with an associate's in architectural technology. I'm now in upstate New York, but Pennsylvania is home.
Pennsylvania is home. Very cool. What really attracted you to the fields you got into?
So I was inspired to get into architecture because of my grandfather. And I actually met someone at PHIUSCon this year who worked on passive solar homes in central Pennsylvania. And my grandfather was the plumber on those projects, which is new information to me. But really, the sustainability focus of the architecture program that I went to really inspired me to get more into this field. I found out about PHIUS during a passive design semester. That was the focus of one of our studio classes. And I had the opportunity to attend the Getting to Zero Forum in New York City the year after COVID. And I saw Lisa White present on an intro to PHIUS, and I was sold from there. I cornered Lisa and asked her about internships, and the rest is history. So I've been with PHIUS for about coming up on 4 years. I've been full-time for 2 of those. But yeah, that's my story.
And that's neat about learning about something your grandfather did. You had no idea.
I had no idea.
Do you know how many houses that he worked on like that?
No, I'm not sure, unfortunately.
Well, that's pretty cool. There's a legacy going on there, I guess, and you're carrying on the family tradition, as they say.
Yeah.
Al, how about you? How did you get started in this? And what are some of the things you do now?
I'm from the Chicago burbs and was one of those kids that they always told you, like, hey, you're good at the math and the sciences. Like, you should go do something with this. Ended up going to engineering school, and I started out as a mechanical engineering student. And like any good 18-year-old, I had a dream. I wanted to go work for Ford. I wanted to work on the Mustang. Like, fumes and perfumes was all the rage. And I had got this job at a high school. At my high school, I had graduated from after I had graduating to save up some money for college. And they asked me, what are you going to study in school? And I said engineering. And they shoved me down in this basement boiler room with two guys almost as old as the boilers they were taking care of, and said, these are the engineers. Learn from them. And I really did, not realizing completely that design engineering and running a building as an engineer are two completely different worlds. But I learned about, yeah, right.
Very different worlds.
I learned a lot about end user experience, especially with mechanical equipment. And when we were trying to pull a 12-foot coil out of an air handler that only had 6 feet of clearance on both sides, it got really exciting. And they said, don't ever do this if you would end up designing buildings. And then I took a class in the mechanical engineering department called dynamics, which was when all of the physics started to move and the calculus got involved and didn't do so hot, and realized that I could go out the architectural engineering way and not have to take this course. So I changed majors and said, I'm going to do HVAC design anyways, just to avoid taking one class. And it ended up being one of the best decisions I'd ever made to switch and learn more about the whole building sciences, and spent my summers interning at MEP design firms, doing a bunch of commercial office fit outs was the bread and butter of the one firm I worked at. So that was a really great learning experience because I got to do a full 10,000 square foot office fit out, full mechanical, electrical, plumbing, and fire protection design once a month. And I'd burn through those and do all the design work and hand them to my supervisor. He'd mark them up. It was a very formative learning process. And then in grad school, I got into the energy modeling thing because it was all of the math and the science that I liked about building design, but was focused more on the holistic big picture. You had to know just enough about every aspect of the building to be dangerous. And we're in a bit of a renaissance right now with the amount of computational power we have to do more advanced analysis and solve as many problems as we can up on the design front of things before we go into the field and have to do some of that final verification and nudging. So that was really interesting. And then a very formative part of schooling for me was the DOE's Solar Decathlon Design Challenge, or Race to Zero, as it was once known. And now it's the Building's Next competition. It's gone through a couple name changes. But I had presented at that, and just like, hey, I had chased down Lisa at one of these. Katrine Klingenberg was one of the grand jurors that year. And after I had presented, she was in the room that I was presenting in. She walked up and just shoved her business card into my fingers and said, call me. I said, okay. PHIUS is my first full-time adult job, and I've been here just over 5 years now, and I've loved every minute of it.
Well, that's definitely a big shift from working on Mustangs and building cars.
I've never built a car. Maybe one of these days I'll get there, but
that's quite a path and a definite change in the middle. What do you find rewarding about working on buildings now and working with, we'll say, making buildings more resilient, more comfortable?
Buildings are very complicated machines, and there are so many different systems and aspects of it that all have to sit at a very happy, harmonious point in order for it to work perfectly. You can't have a really great HVAC system, but have a very poor leaky enclosure and expect it to perform great and be comfortable. But I also can't have a really great enclosure and then have no ventilation, because now people are going to die of carbon monoxide poisoning. Like, trying to find the optimal range or optimized point, how all of these things interplay, is really challenging. I think that's a fun puzzle to solve, as well as buildings are ubiquitous. Everybody spends time in buildings. So the work we do and the betterment we can make in the built environment impacts quite literally everybody. And I don't think there's another field out there like that.
Yeah, I would say probably very, very few that you can affect so many people so widely. for years and years and decades and maybe centuries even to come.
Yeah.
Awesome. So what I wanted to have you guys on today to talk about is this a PHIUS? It's a standard, correct? It's a program as well called Revive, which is for retrofit buildings. And that's a bit of a departure from PHIUS's normal model. Am I correct on that?
Yeah. I mean, all of our current existing programs are built around new construction. We have had a handful of retrofit projects, but they've all had to meet the new construction standard. And we had a little allowance for some amount of unmitigatable thermal bridges. We don't expect you to pick your building up out of the ground and then wrap your footer and put the building back in the ground. That's asinine.
That's difficult.
Very difficult.
You're going to need a lot of big helicopters.
I'm from Chicago, where they raised the entire city in the 1800s 6 feet to solve the sewer problem. And they would have people in hotels while there were like 6,000 guys with jack screws in the basement slowly lifting it up. But really fascinating. But yeah, that's not something that's sustainable that we can do en masse in a retrofit scenario. So even though we've had successful retrofit projects in the past, we were tasked with how can we respond to retrofitting buildings that's going to deliver a lot of the benefits, the health, the safety, the durability, the quality of the interior environment, the comfort that we normally advertise as co-benefits of passive building. How can we deliver that to retrofit projects with maybe a little less investment in the thermal envelope, or a little give and take than we would for a new construction project?
So this standard came out in 2024, if I'm looking at this correctly?
Yeah.
How long was it in production? Haley, if you want to take that one.
It's been a long time coming. I can't give an exact number of years, but I don't know what has it been?
I think Graham Wright, our chief building scientist at PHIUS, gave a presentation at PHIUSCon 2021 in Tarrytown, New York, about some of the original vision for this in terms of resilience and health and safety. And we started work January 2022. So when our full release was August of 2024. It's like 2.5 years of development into that standard.
I got to say, as somebody that has sat on a few standards committees, that's a pretty fast development time.
Yeah.
Especially for something, this standard's 130 some pages long. That's a pretty fast development time for that size of a standard. So I got to take my hats off to you for getting it done. That's a good team you guys have there working on that. Let's talk about some of the overview of this standard. I mean, you touched on a few things there. What are some of the differences that really stand out to both of you between the normal new building standards that PHIUS has versus the Revive program?
Yeah, so we've defaulted to comparing the performance metrics of the new Revive standard versus the old. So in our standard new construction program, we have the established heating and cooling targets and the source energy target. And those are the performance metrics that you have to meet for new construction. For Revive, we're replacing those heating and cooling targets with thermal resilience requirements. So that's the ability of the building to protect its occupants during a 1-week outage period in both the summer and the winter during an extreme weather event. And then that source energy target is being replaced by a life cycle cost analysis, essentially. But still with both, you're getting the benefits of the PHIUS standards as a whole, indoor air quality, very rigorous quality assurance process.
Yeah, and Haley's done a lot of work on building out a bunch of workbooks and checklists and stuff to support that quality assurance process. We're more aligned with the ASHRAE Guideline 0.2 commissioning process in the Revive standard than the traditional Energy Star multifamily new construction or Energy Star single family new construction and the Zero Energy Ready Homes programs that we relied on for a lot of our QA/QC baselining in the past. And then probably most starkly different, like Haley said, is this resilience, this idea of thermal resilience. And in order to distill that down, and we've had to build a whole new calculation protocol and software tool to support that goes by the ever creative name of ReviveCalc. So.
You guys spent a lot of time on that, it sounds like.
Yeah, for sure.
But I like it. Sometimes simple is best there. That was something that really stood out to me when I read through the foreword on this a little bit. Can't say as I memorized all of it, but that resiliency metric was a big thing. And when you're talking about that temperature resiliency, is that maintaining the normal set point in the house during that extreme weather event and the ability to do that?
No, just for clarity too, we're going to define thermal resilience as a building's ability to maintain habitable conditions when the normal space conditioning system is rendered inoperable due to either system failure or what we're more concerned about is like an electrical grid failure. So we're seeing a lot of push for the electrification of buildings to decarbonize your space conditioning systems. I live in a cold climate. And if we electrify all of the buildings right now, we're going to more than double our peak capacity on the grid, as well as we're going to shift the grid peak from the summertime to the wintertime when we need the heat more. And there's a strong correlation between extreme weather events and grid instability. Like the two memorable events that were very prevalent to us when we were developing the standard was the Pacific Heat Dome in the summer of 2021 in Portland, Oregon and Seattle, Washington. They had 116 degree heat dome for 2 or 3 days. And then earlier that year in February was the deep freeze in Texas when people were burning furniture in their homes to try and keep warm because all of their heat pumps failed because they had no electricity. So no, we're not going to maintain 68 Fahrenheit in the wintertime in our homes, but we're utilizing a metric called set hours. That's the standard effective temperature for the wintertime that comes from ASHRAE standard 55. And it's a physiologically derived human thermal comfort metric that you can push to the extreme. So we have a limit of how many hours you can be below this temperature set point in degree hours. And it takes into account as well the amount of clothing you're wearing, your metabolic rate, a handful of different things like that for the wintertime. And then for the summertime, we're looking at a couple different metrics as well. Right now, we're mostly aligned with heat index and saying that we want to see 0 hours in danger or extreme danger on heat index. So again, we're not talking about comfortable, we're talking about habitability.
Gotcha. That's a very good distinction, and I think a pretty important distinction there. And so you're talking about the ability for the building to be habitable essentially without a mechanical system for up to a week then in an extreme weather and complete system failure event.
Yeah.
So that's a pretty big thing. Now, when we talk about a building that will do that, it's probably not even going to need a huge capacity-wise mechanical system in it.
Yeah, and I think that's traditionally all of the PHIUS new construction metrics are trying to reduce your ideal air load. Like, how much heat do I need to supply to the building? Can I reduce that down? And if you look back to like the super insulation movement in the 80s and the passive solar movement of the 70s, it was, can we get by without a heating system? We heat the house with a hairdryer. That was the focus that they had. And all of this evolved into let's regulate space conditioning metrics. So inherently, when you move from a code constructed building or an existing building to a passive building, you will see a reduction in peak equipment sizing to make that happen. And I think when we're flipping those benefits around and we're no longer looking at the energy and the heating load as the primary metric, but looking at this thermal resilience, it's another way of looking at heating, but the occupants are the heaters. Can we maintain this reasonable condition with just that heat from the occupants alone? And that's where we're going to see significant, because in order to achieve that, it's all envelope upgrades, insulation, air sealing, windows. And once you do all of those upgrades and you've improved your thermal envelope enough, then that heating capacity, especially with this retrofit scenario, the heating capacity and the cooling capacity of my equipment can go down significantly. Right now, if we were to take a 100-year-old home, a 2,000 square foot 100-year-old home, we might be putting in like a 5 or a 6 or a 7-ton heat pump to meet that wintertime heating capacity. And now we've oversized it for summer, and we're also introducing a huge peak load on the grid. But if we focus on the resilience retrofit first to tune up the thermal envelope so it's good enough for this resilience idea, then the mechanical equipment we're able to install in there is at least half that size, if not smaller. So we're reducing the equipment size, we're reducing the refrigerant charge in there. We're concerned about refrigerant leaks and their global warming potential. And then we're reducing that peak load on the grid, which is better for grid stability. And also then you have lower electrical costs, lower equipment replacement costs. So how much work can we do with that envelope first is the question.
As we know, everybody loves more square footage in their house and doesn't like putting ductwork around. So the smaller equipment, the smaller the ductwork you got to run around the house, which is another benefit. That's good for those architectural engineers and the architects.
Yeah.
You can hide those ducts better. Haley's really smiling over there right now. She's thinking, yeah, now I can make it look better. So how does this work? Is it an all or nothing program, or are there certain steps that people can meet if they say cost-wise they can't meet the whole program or they don't want to meet the end goal of that program? What can people do to step into this a little bit?
Yeah, do you want to talk about the phase stuff, Haley, and the investigation?
So for any retrofit project or a project that involves an existing building, the first step is to figure out what you have. So the first step is the assessments and investigations, and that in the standard currently involves going through the EPA Energy Savings Plus Health guideline. And that guideline hits on a ton of priority issues that all have to do with indoor air quality, like radon, combustion equipment, lead, garage pollutants, anything that you can imagine that would negatively affect your indoor air quality. This guideline breaks down what to look for and how to correct it. So, yeah, the first piece for a project pursuing the Revive standard is to figure out what needs to be resolved according to this guideline. Another piece of the initial assessments and investigations are site and climate hazard risk. So we have some prescriptive requirements for earthquake, flood, hail, structural high wind, ice damming, and wildfires. So based on what, for example, seismic design category your project falls in, we have prescriptive requirements on how best to mitigate any risk involved with earthquakes. So just completing those initial assessments can get you really far in terms of just improving the safety from an air quality perspective and from a structural perspective.
So that gives you your starting point of where you're at, and then the standard gives you an ultimate goal. How do you step into figuring out what to do first? Or maybe figure out what the low-hanging fruit is on a project? What's the best bang for the buck at that point? Because I think in retrofits, a lot of times it's going to be, we've got this thing and we want to make improvements, but what's the best bang for my buck to get towards that goal?
Yeah, we fully realize that the budget on these retrofits is tough. So the tool that we've developed for it, the ReviveCalc tool, is set up to run multiple cases. So you can look at a cadre of options in there and see what combination of window and wall and roof performance or insulation or infiltration, how can I distill all of this down into a package that would meet those end requirements? And then the standard and the workbooks and everything else that's built around it is supposed to support a phased retrofit, because especially if this is where you live, it's really hard to do a complete gut rehab and live in it for a year.
It's hard to move into a motel or another house for a year or two while all this is happening.
Generally, the best guidance I think we can offer for that is priority number one is solve any existing deficiencies that you might have that are making life difficult right now. If your roof leaks, replace it. If your furnace doesn't work or your air conditioner is rusted out and broken, you can replace that too. It's okay. But also try and find some synergies in there. So if my roof is leaking right now, when I go and replace my roof, can I add some insulation? Can I be doing some air sealing up there while I have all the shingles off and then put the shingles back on or the new shingles on? If I am going to be replacing my furnace, if I can try and do some of my envelope upgrades in the same thing, or replace the windows and the furnace at the same time, or start making those maneuvers, that's where you're going to find some synergies. Dollar for dollar as well, and especially with these resilience things, air sealing is going to be the best return on your investment. it's not super material intensive, but just to get in there, and especially in a lot of the existing buildings, because they are so leaky, all of that air sealing is going to make a huge impact right up front. That will potentially even allow you to install that smaller piece of equipment as you move forward on the rest of your envelope upgrade.
And so the ReviveCalc then is going to detail all this out for somebody that obviously puts good value or good values, good data into that. It's going to detail out what the cost of everything is as far as what the benefits are on the back end as well. So it's going to compare that between the two, if I'm understanding that correctly.
Yeah. In the standard, we've also prescriptively outlined, I think it's 4 or 5 different envelope packages just as a starting point to evaluate. So you can take your existing house geometry, set up your baseline case with your best guess, or if you've done an energy audit, that might help you input better inputs into there. You know how much insulation you have. You've done a blower door test. You know what your infiltration rate is. You can input all that into the tool. And then there are a couple different envelope upgrade packages. There's a light touch where you're just going to do a little bit of air sealing and maybe add an inch of insulation to the walls. There's one about bringing the house all the way up to current IUCC 2021 code. There's one that's that plus a little bit of air sealing. And then the top tier of those first outline packages would be a full-on PHIUS new construction. So you can run through all these different cases and see where's my happy point, and then maybe you can mix and match things in there. We haven't built out a full optimization engine on the background yet, but it's something I'm working on. And the end vision for this is that we're going to be able to upload what the house is, what the baseline is. You can look at a menu of all of the different possibilities you could do. So if you've got a stud wall, you would select all of the options that use stud wall that fit within your building's footprint. But I'm not going to pick something for a masonry wall, for example. Pick all the options on there, let it run, and automate some of that energy consultant analysis and run 1,000 cases of possible building upgrades. Spit out the 10 lowest life cycle cost or lowest upfront cost cases that you want to look at, and those become project specific prescriptive paths forward. And I'm a big believer when we run optimizations in giving people back an optimal, like a top 5 or top 10 cases rather than a single optimized point, because then it allows for some interplay and design decisions. And we're fighting over a 1% difference in energy. Is the juice worth the squeeze? I'm not going to lose any sleep over that. But within there, you could find, if your cousin Larry does attic insulation, you could pick the one that's got a little bit more insulation in the attic and a little less on the walls or something like that.
What does the process look like if somebody just wants to get started with this? Who are they going to contact? Do they go to PHIUS? Do they go to a private practitioner to get started with this process?
It would be a CPHC, or we here at PHIUS love to do feasibility studies, and we're very willing to help teams navigate this new standard. I think we've done maybe 4 or 5 feasibility studies to the new Revive standard at this point, and all of them are very eager to go through the certification process and generally feel a lot more comfortable navigating the process after doing the feasibility study. So, yeah, we're here to support, but we want our CPHCs to be empowered enough to be able to guide their clients down the path of Revive 2024. So, yeah, CPHC or PHIUS.
I'm going to ask you a next question then. What's a CPHC?
CPHC is our certified PHIUS consultant now, I think is the new term. But a CPHC goes through our CPHC training and should know the basics of passive building design principles, super insulation, your air tightness, balanced ventilation, etc.
So what's a process look like then? How long does it take to get a CPHC designation?
The first part of CPHC training is a self-guided course. So that's really at the discretion of the person pursuing their CPHC certification. And then there is a live training, a virtual live training to that, which is, I believe, over 2 weeks. It's like 4-hour sessions over 6 days. The live session training really gives you the tools you need to pursue PHIUS certification, how to create your balanced ventilation plans, how to balance a ventilation system, what details need to be shown for certification, and all building on those foundations that they would have learned during the self-guided part of the training. And then at the end of the training, there is a design exam. So you have to actually put together a plan set and details to be reviewed by our PHIUS graders in order to obtain the certification. And there's a written exam as well that is all on the foundational knowledge given in the self-guided portion.
That's good to know. I want to make sure that everybody understands what these acronyms mean here, because we work around a lot of industries with a lot of different acronyms. Let's face it, sometimes they get a little confusing. So can anybody go get that certification? Is there any prerequisites? Do they have to be an engineer or an architect or something to get the CPHC?
Nope, there are no prerequisites to becoming a CPHC.
Gotcha. I want to ask both of you, what are your favorite things about the Revive program? Haley, go ahead. You look like you got a thought in your head.
I'm just excited overall about trying to tackle the existing built environment. We've been so focused on new construction at PHIUS, and reusing something that's already there is one of the most sustainable things you can do. And there are so many people living in poorly insulated buildings. I grew up living in apartments where my family faced the burden of energy costs. It's fulfilling to me to be working on a standard that hopefully tries to solve what I've experienced all my life.
Very awesome. Al, what about you? What's your favorite thing about the Revive standard?
I'll echo Haley a little bit about living in a uninsulated home. I live in a 1915 stick-built bungalow on the south side of Chicago. And I just this past weekend insulated and air sealed the floor of my son's bedroom because there was no insulation and no air sealing on it. And it was very cold in his room. So I felt bad. The expression, the shoemaker's children always go barefoot, rings very true for a lot of us at PHIUS. But to me, I think the most exciting thing is the building out this whole new methodology and software tool and trying to bring in some of that computational power and distill it down for the end user. The tool that we've set up is building a full dynamic energy model in the background, and it runs this resilience analysis. So it runs one energy model for that. It runs another energy model for annual normal operations to get lifecycle costs, and then it does the lifecycle cost analysis on the back. And that's a lot of computational oomph that happens. And we've distilled that down to about 55 or 60 inputs, which I'm incredibly proud of, that we can make these like very detailed analyses accessible to the masses.
That's pretty impressive with such a low number of inputs. As someone who has done a few load calculations around and worked with that, that's pretty impressive. Can people access this tool publicly, or is it something that is for CPHCs only?
Right now, ReviveCalc is currently 100% free. If you like the dulcet tones of my voice, you can listen and watch all of the training videos that I've developed on how to utilize the software. And you can find a link to the GitHub repository where it lives on the PHIUS website.
Very cool. What's the way to find that on the PHIUS website? Now, this is at PHIUS.org, right? PHIUS.org?
Yes, PHIUS.org. In the middle of it, there's one for standards. If you click on that, there's an option for retrofit, and there's an option for Revive 2024. And then there's a whole bunch of links to the standard document, the workbooks that Haley mentioned earlier, and a link to the software tool as well. And that software tool was completely developed in-house. So we're constantly making improvements to it. And I think I have a new version that I'd like to push out no later than Thanksgiving.
Well, I got to say personally, I was very interested to learn more about this. It looks very, very promising, as both of you said, for the masses to use, because we've got a large number of existing buildings out here. And I, for one, don't like to see them torn down. I like to see them, let's keep using them. Let's make them better if we can, and allow people to stay where they're at and maybe not have to move into something new or spend the time to and the energy to make something new. So I'm really excited to see this come about. and make this happen to help everybody use those existing houses. So congratulations to you guys and your team for getting this done and getting this out here. I'm really excited to see it, and I'm going to be watching. I want to see how this works out, and hopefully we'll see some more projects going for it.
Yeah. And we've got one project that's completed the first phase of certification.
First 2 phases.
The first 2 phases.
Yes, assessment and design certification. So they are design certified and they're in the construction process right now.
And that's a project that's local, me in the Chicago area. And I was talking to the certified passive house consultant on the project at PHIUS. And it sounds like we might even be able to convince the client to do some actual functional testing where we show up and put a bunch of hobo loggers around the house and turn off the heat for a weekend and see what happens. So we'd like to try and do more in situ field validation of some of our modeling methodology.
That would be very cool to see how well your ideas worked out and how good that software really is. We're about running out of time here, so we're going to wrap this up. Al, any last thoughts as we close this out? Anything you want to share with our listeners out here?
It's partially my bias based on what I do, but we live in a world where we have more computational power than has ever existed before, and let's use it for good and design better buildings.
Very cool. Haley, how about you? Any last thoughts? Let's close us out here.
I guess I'm just excited to see where the standard goes, and I'm excited for people to try it out. And like you said, we have so many existing buildings. I also want to see them remain, and I want to see them do better than how they stand today. So excited for the future.
Awesome. Haley and Al, thank you very much for joining us today on this episode, and we look forward to seeing more out of the PHIUS Revive program as it evolves and the world gets to use it a little bit more.
Cool. Thanks for having us.
Yes, thank you.
Thank you for listening into this episode of the Building HVAC Science podcast. We encourage feedback and comments. You can reach us at marketing@truetechtools.com. That's TRUTECHTOOLS.com. You can follow us on Facebook by typing Building HVAC Science into the Facebook search bar. Some of the topics we discuss require technical training for proper interpretation or safe execution, so if you're a trained pro, you can proceed immediately. If you're not, please consult with and hire a trained pro. The Building HVAC Science podcast is a production of TrueTech Tools Limited. Full disclosure, I'm the owner of TrueTech. Any opinions expressed are those of my guests, my co-host, or myself, depending on who is speaking, of course. If you're in the market for any tools or test instruments mentioned in the podcast, look at what TrueTech Tools, our company, carries, TRUTECHTOOLS.com. You can use the offer code HVACBS for a nice discount. I want to thank you for listening to and hopefully following the Building HVAC Science podcast. Please share the episode if it struck a chord with you. Let your colleagues know what you're doing and what you think is important, and we hope it's us. Thank you very much and take care.